Welcome to this course on the stereochemistry and reactivity of organic molecules and intermediates, a problem solving approach. At the outset, let me point out one thing which is more or less universal, that is the fear of tackling this subject of organic chemistry. So, naturally the question comes that what it is there in organic chemistry that the students are afraid of. What is there in organic chemistry that the students approach this subject with some sort of apprehension. Now, during my several years of interactions with students who are reading organic chemistry, my impression is that the way the organic chemistry is taught to the students, it gives an impression that organic chemistry is a subject full of memory. So, you have to memorize lot of reactions, and then you have to memorize lot of pathways, and it is also very difficult for them to predict the outcome of an organic reaction. Okay. I do not blame them, because that is how the organic chemistry has been taught over the years. However, although it is true that organic chemistry is full of reactions and full of different outcomes for different reagents, it is true that you can master this organic chemistry provided you have a solid foundation of the understanding of the basic structure, the stereochemistry and the electron distribution around the 3D space in an organic molecule. I think that is very vital. Once you grasp that, once you have that understanding, I think you can then dispel this fear of tackling this subject, and it can only be seen by solving a number of different types of problems. Okay. Now, this course is primarily aimed towards the following. One is to give a very good foundation on the advanced level of stereochemistry, and including the symmetry that is so important in providing the orbital diagram and the reactivity profile of organic molecules. Not only organic molecules, molecules which have a 3-dimensional shape, and the stereoelectronic requirement of various reactions. Remember that all reactions try to go through a pathway where the electrons are arranged in such a way in 3-dimensional space, so as to give the minimum possible activation energy. So, that depends on the orientation of the electronics around the different substituents or atoms at the. So, basically an understanding at the atomistic and the electronic level is very important. And finally, every molecule, although we draw the structure, but it has an inbuilt geometry associated with it. Okay. And this geometry, that means the 3-dimensional structure of a molecule, can only be sorted out through various spectroscopic means, and in this course we will introduce the subjects which are called optical rotatory dispersion methods in understanding and elucidating the structure of organic molecules with the help of what is called ORD and CD, circular dichroism. Okay. Now, all these topics will be backed up by solving a series of problems, so that ultimately you can master these subjects. Not only that, you will learn how to enjoy the organic chemistry. I will be supported by by my TAs, whose names will be announced later in the website, and they will tackle your day to day questions, the queries, and also there will be weekly assignments which you will solve, and we are always eager and free to listen to your thoughts, to your queries, to your questions. Thank you.